Hello guys, so welcome back to our eighth lecture. So we still have 3 points to cover in Karnaugh map. Okay, we're gonna cover two of them in this video and the next video, and the last point will be basically a key for the next method that we're gonna learn, which is a tabulation method. So we're gonna postpone this point, the third point, to the next week, lecture 9. Okay, so the first point that I want to highlight is that it's actually an answer for two basic questions. Till this moment, we learn how to get, or the result of the Karnaugh map minimization is basically sum of product. How about if the designer is more interested in getting the product of sum? So based on what we learned so far, we can get the sum of product out of the Karnaugh map, then we can convert it, and we learn how to convert a sum of product into a product of sum and vice versa, last lectures. But the question, can we get that directly out of the Karnaugh map to make it in one step, not two steps? And the answer is yes. And this is what we're gonna learn, in this video. The second question is also a legitimate one. What if I was interested in f bar? I mean, the complement of the function, not the function itself. Okay. So again, intuitively, we can get f out of the Karnaugh map. Then we can take the complement and use De Morgan's and stuff. Okay. It's again two steps. Okay. The question is, can we get it out of the Karnaugh map directly in one step? And the answer again is yes. And we can also learn this out of this video. Okay, but what is the idea behind that? So the basic idea is also something that we learned, is that you can express a function as a sum of min term, which what we have done so far using Karnaugh map. And using Karnaugh map, we are minimizing this this sum of min term, which is basically grouping the ones, and they get some minimized expression, sum of product. But remember, for each minimum term, there is a max term. This was 1, this was 0, if you go back to this lecture. Okay, so if we look at the zeros of the Karnaugh map and group the zeros now, not the ones, then we can get product of sum. Another interesting thing we can do is that by looking also at the zeros, we can get the complement of f. So if we group the zeros and shape these groups that we're gonna get into product of sum, then this is f, but in a product of sum. But if we shape the, or express the terms or the groups that we're gonna get by looking at the zeros as sum of product, then we get f, or I'm sorry, f complement. So it will be more clear if we take an example. So the example here, we have just, a function of 4 variables, a, b, c, d, okay, represented by these main terms here, 0, 1, 2, 5, 8, 9, 10. And there are 3 requirements in that problem: getting the sum of product, which is the things that we do all the time using Karnaugh map, and then get it as a product of sum, which is a new thing that we're gonna learn, and then get it as its complement, f bar. So the solution is there, but the solution is for the product of sum directly. So let's do A first. Let's do A. Let's get f as sum of product, the thing that we do all the time. So we will look at the ones. So just ignore the grouping that made for zeros here, because this is a solution from the book, and I'm gonna look at the ones now to get sum of product. Okay. Again, let's start by the most isolated ones, which is this guy here. This guy is isolated. Okay, isolate means the number of adjacent ones is small. Okay, so we don't have much options here. It's only one option, this guy, to group this, to have a group like this. Okay, let's now check what's constant, what's varying. So for this group, we have a bar. So f equal to a bar. For this group also, we have B is changing, because this is B bar. This is also B bar. This row is B bar. This row is B. So B is changing. How about C? This column is C bar. And no change for C. How about D? So this is D bar, this is D bar. For that column, we have only D, so no change for the D. So the first term here is A bar, C bar, D. And you can always check on yourself. Okay, the number of reduced variables, just log 2 the number of ones in the group. The group has 2 ones, log 2 for 2 is 1. So we reduced here 1 variable, which is B. Okay. What else? Looks like this guy is also a little bit isolated as well. You may say we can take this group. I will say this is not optimum because basically remember this edge here and this edge, the folding is connected. So we can take these 4 ones together. This 2 with this 2. Now let's see or check what's varying, what's constant. So this row has A, this row has A bar, so A is not with us here. For B, this is B bar, this is also B bar, so we have B bar in that case. C, yeah, it is, these 2 columns are C bar, so C bar is with us. How about D? This column is D bar, this column is D, so it's a change. Okay, now we have 2 ones left. Okay, and again, our trick, the 4 corners are connected. And we have here in the 4 corners, we have ones. So we're gonna take, let's do it with another color. So we're gonna take this one here, with this one, with this one, with this one. Let's check which is constant, which is varying. This row has B bar. This row is first A, this row is A, this row is A bar, so A is not with us. But this row is B bar, this row is also B bar, so B bar is with us. How about C? This column is C bar, this column is C, so C is not with us. How about D? This column is D bar, this column is also D bar, so D bar is with us. Okay, so this is F. Now let's do B. Actually, B is already done because you know the solution is there. I mean, it's highlighted already. So for the sum of product, we're gonna look at the zeros, and for each group we will express it by its as a max term. I mean sum of things. Okay. So you know this 0 here was isolated. So better to take this group here. Was 4 zeros. Okay. And for this group, we have A not changing. So if as a sum of product, or product, I'm sorry, product of sum, if equal to. Remember, this is yes A, but as a sum, as a max term, we're gonna express it as A bar. A bar. What else? This row is also B, but we're gonna take it as B bar plus B bar. What else? So these 2 rows is C bar. These 2 columns. The first 2 columns is C bar. The last 2 columns is C. So C is changing. We not consider it. First and last column are D bar, but the middle columns, 2 columns is D. So it's also changing. So the first max term is A bar plus B bar. Okay. So again, we are expressing the zeros. We are expressing the zeros, not the ones. So we are looking for the values that will make this term here 0. Okay. Okay, now let's continue. What else we have? So these 2 zeros is not considered yet. Again, this edge is connected with this edge, so we can take this as a group, these 4 zeros together. Okay, for these 2 zeros, this column is A bar, this column is A. So is it changing? We not consider it. For B, both are B. Yeah, both are B. So this is B, this is also B. So B bar, remember. How about C? This the first column is C bar, the last column is C, so C is changing, but the first column is D bar and the last column is D bar, so plus D. You always invert. What you did with F, you do the opposite with I'm sorry, in sum of product, you do the opposite with product of sum. Okay, we have still 3 zeros left. Then we take this group, the final group here, this column here. Let's check. So the first two rows is A bar, the last two rows is A, so A is changing. For B, first and the last rows are B bar, but the middle rows are B, so B is changing. But this column is D, but this first C, so this column is C and also D, so C bar plus D bar. Okay, that's basically how to do product of sum out of the Karnaugh map. Now, number C, the complement of F. Again, we're gonna look at the zeros, but we're gonna express them just as what we did with sum of product. I mean, let's do that. Let's do that. So we have here the same three groups. So this group, we have the group here. We have this group, and we have this group. Okay, so let's start by this group here, this third row. Okay, so we're gonna again do like what we did with the sum of product. So here we have A and B, and C is changing, D is changing. So this will be basically A, B. Okay, not A bar, not like the max terms. Plus, it's a sum of product. So the second group here is the group on the edge, is this group on the edge. So A is changing because here A bar, here is A. B is not changing because this two rows is B. C is changing because C for the last two columns is C, and for the first two columns is C bar. Okay. For D, D is not changing because this is D bar and this is also D bar. So B D bar. Plus this group here, this group A is changing, B is changing, C is not, and D is not. So this is B bar. I'm sorry, this is F bar. Can we check? Yes, you can check. Just look at the max terms. So F here as a product of as a sum of product equal to A bar plus B bar multiplied by B bar plus D multiplied by C bar plus D bar. What if we have taken the complement? So we're going to take the complement for all of this. So when you do the complement for all of this, this will give you plus complement here, B bar plus D complement plus C bar plus D bar complement. What is the complement of this? Again, De Morgan's AB plus what is the complement of this? BD bar. What is the complement of this? CD. Just to compare CD, CD, BD bar, BD bar, AB, AB. Okay. So this is basically, a very good example because, we answered our questions with a practical example. And at the same time, we just verified that we are on the right way. Okay. Because when we did analytically F bar based on the product of sum, we get what we get out of zeros, Okay, guys. So this is basically, the first observations that I wanted to point out about Karnaugh maps. So stay tuned for the next video. We're gonna also, discuss another, point about Karnaugh maps as well. Then we continue next week. See you. Bye bye.